Hello, everyone. I'm John Levine of Levine Electronics and Electric. We're a manufacturer's rep that covers Georgia, Alabama, Florida, Tennessee, Mississippi, and Arkansas. We've got two divisions, a control division and a power division. Please check out our website at www.l-3.com. Our philosophy is to give back to the industry to make it better and safer for everyone. Michael McClellan, our marketing director, has been running these webinars almost every day to help our customers. You can find these recordings that we've done on our resource page. We probably have over 50 videos now posted. We're known as the protection, transformer, arc flash, and grounding experts in our territory. If you have a question, you can type it in the chat, and we'll try to answer those at the end. I've also got 4 handouts for you, one of which is the PDF version of this presentation. We've also got 2 poll questions, so stay tuned for that. When I pull those up, you can answer those for us, so we'll see what kind of results we get. I've also got a short survey at the end. If you could fill that out, it'll help us in the future. I've got it set up where you should get your certificate of completion 1 hour after the presentation. In that, you'll see at the very bottom a little box that says certificate. Today, we've got 2 speakers. We've got Tony and Balu from Control Infotech. I think you'll find that very interesting presentation. With further ado, Tony, I'll turn it over to you.
Okay, thanks, John, and thanks to all of you that have registered for the webinar on cybersecurity and analytics for power control operations, specifically e-houses. I am Tony Lazinski. As John said, I'm a business development manager for Control Infotech, and you'll see my contact information on the screen there. Feel free to contact me or via the L3 representative that calls on you. I like what John said about giving back to the businesses that he supports. My objective for today is to share with you a story that, actually 2 stories that that I've been involved with, where we've been asked to provide cybersecurity services on power system projects. Control Infotech is a system integrator that provides a wide range of systems engineering services. And when about a year and a half ago, we were asked to provide a proposal for cybersecurity services on a generating plant, I learned a lot of things as I went through it for the first time. About a year or 2 prior to that, the company that I worked for, Control Infotech, had been working on other cyber projects, and we'll talk about one of those as well. It's a project for a traction power substation, where a municipal city requested cybersecurity testing built into their specifications so that they could assure safe and reliable operations for the SCADA system that we delivered, that was controlling multiple traction power substations. So a lot of safety and giving back to the community is a big part of what today is about. As a system integrator, we get involved in providing a wide range of services, because when you talk about a system, what you're talking about is integrating different components of a system. One of the key things that we've learned as a system integrator is that we need to be prepared for just about anything. And I'll talk here a little bit about the role of a system integrator as it relates to the number of different people that were involved in each of the projects that we're going to share with you today. And in each of those projects, there were the end users, the EPCs. The EPC had subcontractors, and then as a systems integrator on the project, Control Infotech was asked to participate in a group of entities required to define what the deliverables were and in effect interpret the specifications. So although in many cases you can find specifications defining exactly what's required, in the couple of cybersecurity projects that I've been involved with, there's a good deal of time where we actually have to interpret and be a good team member in figuring out just what's required and what needs to be delivered. So in this case, what I need to do is to work not only to provide, for example, the system integration services that we're typically called upon to do, but also to integrate other subsystems. Some of the systems that we focus on and have provided for over 20 years include networking, server and setup and virtualization services. We've developed cloud-based systems and provided security services and security monitoring for a wide range of facilities. We feature and have engineers on our staff that can design and program and commission and deliver all of the automation and IT equipment. And in that role, we often get asked to tailor our system to a specific requirement. And in this case, as it relates to this particular webinar, we were asked to tailor it to satisfy a set of EPC requirements. And in doing that, I needed to be able to involve a cybersecurity analyst that was capable of working not only with me as the system integrator who designed the SCADA system for the operations technology or the control panels that go with it, but also someone that was familiar with the different standards and methods to verify that when the project was completed, that all of the cybersecurity standards were met and that the facility was compliant with all of the policies that are set forth by the different agencies that govern the facility, whether it's a traction power site or whether it's a government installation, or even we've done some liquid natural gas plants where the owner of the facility had a large interconnection to the utility where their turbines were not only taking power from the heating systems that were on the site, but using those the excess heat to generate power and then participate in part of the black start operations for that utility. So there's a lot of different players involved, and I needed someone that was familiar with not only the standards that were referred to, but also the interests each of the different entities involved in that project, the user, the specifier, the different subcontractors that were involved. And in this case, I've worked with a gentleman that's joined us here on the conference. His name is Balu Subramoni, and Balu has helped me climb the mountain, and he represents the type of resource that I have access to as I respond to different types of proposals for cybersecurity. And Balu's contact information is at the bottom of the screen. And so you've got his contact information just to give you an idea of his, or how to get a hold of him, or how I would get a hold of him. And Balu, can you hear us? Can you tell us a little bit about yourself?
Sure, Tony. Thank you. And my name is Balakrishna. You can call me Balu. I have been with SAM Analytic for the last 2 years, and I've had opportunity to work on industrial control system compliance testing projects. And that is what Tony was referring to. I'm an IT professional and a cybersecurity practitioner. I obtained my CISSP, which stands for Certified Information Systems Security Professional certification in 2014. There are two broad categories of activities in cybersecurity. One is the defensive side, which is also called blue team, and the other is offensive, which is called red team. While I'm a strong blue team advocate, I've also had to engage in red team activities. For this webinar, I look forward to adding value to your understanding of cybersecurity in an industrial control system context. And Tony, I'd like to hand it back to you. Do let me know when I can, when you have questions as you go through this webinar. Thank you.
Thanks, Balu. Again, this webinar focuses on cybersecurity. There are a wide range of services. We couldn't address all of them, but SAM Analytics is able to provide. But there are a couple that I've been involved with that I thought sharing with you might be helpful in the event that you're working on projects, you're seeing specifications, you're being asked to work with an EPC, or you're asking your EPC to develop a set of specifications and requirements to satisfy your concerns about threats, and specifically cybersecurity threats to your system. So we take our knowledge about the SCADA system and incorporate workshops, data analysis and collection of that data, security information and event management, which is a way for us to set up a computer at the site of the facility and continuously monitor the activities of the users as they log on and get authorized and authenticated. And then, as Balu mentioned, we include a offensive as well as a defensive approach to assuring security and your power system. I think when you talk about a red team and a blue team, Balu, you're talking about a red team, I assume, is where you put on the role, you play the role of a hacker, and you
That's
attempt, right. Yep. So you play the role of a hacker. So you get to be an international hacker. And when you're on the defense team, on the blue team, you look at how to protect the valuable information that you have from a wide range of threats, whether it's spoofing or
Absolutely. As a matter of fact, Tony, you have brought it out pretty neatly. There are two use cases that you spoke about. One is e-houses, and the other is the traction power subsystem that we are going to be addressing during the course of this webinar. What you're seeing on this screen is a list of services that SAM Analytic offers. The focus for one use case that we're going to address is compliance management and how compliance management service unfolds in the context of e-house and power generation is what we would look at first. And one of the points here, Tony, is that while you will be talking more about the OT side, the commissioning and the implementation of this project, I'd like you to please also look at the cybersecurity side, and hopefully that will come out in the form of questions. So I'd like to hand it back to you, please.
Okay. As Blue mentioned, we're going to look at the first case is a compliance management. Again, I know there are a wide range of activities. We're going to talk about these, but in the handouts, you have a service catalog which lists in detail the areas that SAM Analytics provides. So these are ones that I proactively promote and include in my proposals. And then, of course, we assess the specifications and the proposals that are presented using the expertise. A group that's capable of providing not just adherence to standards, but helping a company define the standards and guidelines for their operations. That was one thing that I found that was interesting, is the end user and the EPC that we were asked to support. That group of people did not have a set of standards defined yet. And so they were organizing their team members and saying, what are the standards that we need to implement, not just in order to satisfy the NERC Reliability Council, but also to make sure that the owner of this liquid natural gas plant makes sure that their data is protected from anything from an attack to more something, I guess, smaller, but just as difficult to deal with, like a ransomware type of approach. So there are standards associated with the agencies, but also standards that have to be developed for the individual facilities. We're sharing with you the need to, or that need, because you need to expect that, as well as something that includes the ability to monitor cybersecurity events and document how that operation mitigates or takes care of that particular event. And so there are services that are available where, as a systems integrator, we work with the cybersecurity people at the end user and with the EPC to develop the equipment that gets installed as an integral part of the power automation system to track all the authentication and authorization and operational activities for that system. So a tight integration of the automation system with the cybersecurity monitoring system required for event management. Compliance management services, what surprised me there was the amount of documentation that was required. And in some cases, there may be a policy that the NERC CIP standard references, but there are no formal documents associated with how to confirm that you've met or satisfied the requirements of that policy. The vulnerability assessment testing and the is an activity where all of the assets that are identified on that site, and in this particular case, in the e-house, were identified both from a hardware and a firmware standpoint, because in your e-houses and in your substations that you design or that you build or that you operate, those substations have PLCs and RTUs and Ethernet switches that are manufactured by companies, and those companies are required to document what cybersecurity features exist in those products, and then there is a central location where all known threats, where that manufacturer's product has been attacked, is recorded. And so part of the documentation process is actually going to these websites and verifying by part, by manufacturer type, part type, firmware revision, hardware revision, what threats have existed around the world, so that if that relay is susceptible to some kind of activity, that our community can share that information as quickly as the red team, the hacker team might. We also provide basic awareness and training and consulting services through threat assessment, and probably the one that links me as a system integrator to your systems is the ability to integrate these and automate the cybersecurity tasks that your customers are required to do, whether it's time-consuming data collection and analysis, whether it's very detailed documenting and reporting of the events and incidents that occur, or the actual extraction and transformation and logging of data and activities that occur. All of that is time consuming, and you can look to include that in your proposals, whether you're issuing a proposal for request or you're building your proposal as an EPC or a switchgear OEM, looking to offer any of these services along with your ability to deliver power systems and substations. So quickly, there's the first case, as I mentioned, was a generating station. The second case is a traction power. For the first case, there was a generating station that was part of the black start chain of generating sources that are used in response to a blackout condition, and on that in that network of generating sources, there are different loads that were prioritized were prioritized by the regulatory agency as to what type of power they need and which one should get the power back first, or which one should be shed first in order to hold and manage power and voltage stability for the more critical customers on that circuit. In this case, it was complicated because the end user that connected to the utility had a large turbine that was capable of taking the excess heat created in a liquid natural gas process, and then using that to actually generate power and participate in the black start operations. And what I was surprised to find out was that that the NERC standard is written such that it's not only the power equipment, the main primary drivers and equipment used to transmit and distribute that power, but it's also in many cases, and at least in this one, the balance of plant operations that were required for the generating station. And in this case, they were the E-houses that were required to power the cooling water and run the water reclamation and water treatment facility at that site to be able to provide the cooling water for the turbine systems and the generator. As a result, there were multiple E-houses that were just dedicated to different parts of the not only the power generation process, but also the balance of plant. And the NERC CIP standards reference that, and the set of specifications that came out looked like this. And again, this is a seminar that we don't have an opportunity to go into detail on all of the sections of this spec, but suffice to say that the EPC provided a set of cybersecurity requirements in a section of their spec, almost as an attachment. And that attachment, as part of the contract, was involved a commitment and a deliverable on the part of the seller of the E-houses to satisfy not only the power system requirements, but also the cybersecurity requirements for this installation or this facility that's in its construction phase now. In that, the set of specs were wide-ranging, and it includes everything from the access to the systems, definition of not only access to the network that has a routable protocol, meaning it has an IP address that can be accessed, but also any equipment such as a relay, a physical asset, like a relay in a control panel that was going to be connected to that system through a Modbus serial converter. So the list of specifications can be quite detailed and involved everything from the relay to the DCS system. And so the mix of services that are required to even interpret this set of specs requires a knowledge of power systems, automation systems, cybersecurity standards, and the actual power equipment, which includes the transformer monitoring, the circuit breakers, and all the protection and control system that's associated with those items. So we took, or I took, that set of specifications that was sent to me by my representative. So someone like the representative from L3 that calls on you was quoting a transformer or an arc flash study and said, hey, is there anything that you need in terms of cybersecurity? And we were provided that spec by one of the talented reps. Then what we learned is that having that spec required participation in a team where we had to break down each section of that spec and create a table where we defined for all of the players on that project what the deliverable would be, whether it came from my company or not, whether it came from the company providing the SCADA and the control panels, or whether it came from the company providing the DCS system, or the transformer monitoring equipment, or the protective relay. Someone had to sort through that list of specs and generate something that could be used to define deliverables in a contract that could be measured against. And literally, Balu and I had to go through that spec and provide that to the EPC and the end user who were going through this activity for their first time. So I'd have to say that having someone or a group of people that could represent a wide range of interests helped this EPC do their job. And they were quite appreciative of the level of effort and detail that we went into to demonstrate not only what they've specified, but also what deliverables to expect. And in this set of deliverables, we included a wide range of things that we could deliver in our proposal. And a sample proposal is available through your L3 representative that I think that you will find interesting. And in that proposal, we included many items, and it was narrowed down to basically the BES cyber system categorization of all of the assets that were in the e-houses, and a review of the threats associated with those assets with respect to the security management controls for each of those assets. And I thought it was funny, I don't know if it was funny, but as a system integrator, you kind of learn that it's often necessary to get in and define the scope of services before you can accurately quote them. And I was thinking, Balu, why didn't they just provide us with, the list of deliverables to begin with?
Yeah, that's a good question, Tony. And I think
shouldn't they just be able to tell us what to do and then we go do it?
Yeah. So as you had rightly said, cybersecurity is like a jigsaw puzzle, and it is a lot of collaborative work. It is just not one person, in a pyramidal structure trying to orchestrate what's going on. So owing to that, the various stakeholders have or bring in different kinds of knowledge to the situation. And that is one of the reasons why typically users are not able to define the entire scope. It requires different skill sets and requires a team of several organizations to be able to do that. What I'd like to do is I'd like to use this next slide where we're talking about, not a problem, Tony. Thank you. So the idea is that in today's industrial control systems, there are two distinct systems. One is normally called operations technology, and the other is called information technology. And by the way, I may be preaching to the choir here, but I'd like you to please be patient because I'd like to cover the fundamentals and then move from there. So the idea here is that when it comes to operations technology, we are talking about safety and reliability. Whereas when it comes to information technology, we are talking about a totally different set of things, which are referred to as confidentiality, integrity, and availability. Now, IT and OT are very tightly coupled. With the advent of Industry 4.0, the overlap between IT and OT has become so high that IT systems are impacting OT systems in terms of operations. As a result, a weakness in your IT system is equal to a weakness in the industrial control system itself. That is the reason why we need to be very careful when it comes to cybersecurity, because cybersecurity is going to give you the mechanisms and the means to protect your overall industrial control system. And I'd like you to please go on to the next slide, Tony, so that people can see the definitions of some of these words in cybersecurity. So one of the things is confidentiality is I should not be able to access information which is not meant for me. Now, one of the ways in which confidentiality of a system is maintained is by making sure that it is password protected, for example. So password protection is called a security control. So what we do is we look at what is it that you want to protect. Now, what you want to protect is normally called a cyber asset. Now, there are fundamentally three types of cyber assets, or three categories of cyber assets, which are hardware, software, and networks. So cybersecurity essentially is about protecting or securing your hardware, software, and networks within the scope of an industrial control system. So confidentiality, one of the ways of looking at it is to make sure that you don't disclose information to people who are not supposed to access it. Next comes integrity. Integrity is no one should be able to modify information. For example, let us say you have the firmware serial number. Now, this might appear very trivial, but imagine if the firmware serial number were modified, and which means that there is a certain inaccuracy which is stepping into the entire system. Now, that is where integrity has been lost or compromised. So one of the ways in which integrity is preserved is using cryptography. So security controls where cryptography is involved ensure integrity. The third thing is availability. So for example, let us say you want to be sure that the network is available all the time. You build in redundancy. So redundancy, backup, these are all security controls for ensuring higher availability of systems. So I hope you're getting an idea as to what cybersecurity is in the context of an industrial control system. Now, can we just move to the next slide, please? Now, the idea is I want to somehow assure, this is what Tony was talking about earlier, where I want to assure as a seller or a buyer, I want assurance that the system that you're going to put together as engineers works from a cybersecurity perspective. Now, the way we do that is through the concept of what are called security assessments. So an assessment is nothing but a process of determining that a particular secure information system is meeting certain security objectives. Now, there are fundamentally two things. You have self-assessments and you have third-party assessments. Now, in most situations, large organizations sometimes are capable of having their own teams which do self-assessment. Oftentimes, the cost of doing self-assessment and retaining people to do self-assessments can be prohibitive. So organizations also tend to outsource this activity of assessment to third-party assessors. Those are called TPSAs, or third-party security assessments. So essentially what we're doing is that when we talk in terms of compliance management, we are talking in terms of security assessment to try and understand if a particular organization or if a particular set of cyber assets are in conformance to a particular standard. So this is what we did in terms of Tony and I worked together on this project, which is what we're trying to share with you. Can you please go on to the next slide? Now, what exactly did we do? There are several standards that came into play, and what is on the screen is some of these standards. I've also pasted the first link in the chat window so that if you are interested and as you're listening to me, you can also go on to that particular web page. So the CIP, or the critical infrastructure protection, right, is It's called NERC CIP popularly. And what we are talking about is the NERC CIP standard, which we'll talk about in the next couple of slides. But right now, I just want to quickly tell you something more about NIST. NIST, the National Institute of Standards and Technology, they have come up with a host of standards and guidelines. And these are normally called special publications. So NIST, Special Pub 800, the entire series, it all pertains to cybersecurity. There is also another resource which is useful, which is the CISA. So these are some of the resources that you can use when it comes to your own cybersecurity in regard to industrial control systems. You can always get back to us. We can help you out in many, many situations.
Well, these can actually be part of additional webinars. If you're interested, you can contact Mike McClellan and say, yep, we'd like some additional follow-up, but we'd like to have an introduction or an overview of the actual standards. So that's something that
Yes.
L3 can provide to you.
Yeah, a very good point, Tony. In fact, that is what the Security Awareness and Training Service is meant to do. So we take on one-off assignments, or we take on a more systematized approach where an entire organization's people have to be trained to a particular level of skill. So there are standards, again, in terms of training itself, which we try to follow. So we are basically driven by the NIST standards in a broad way, but we also tailor it for customer requirements, most of our cybersecurity services. So coming back to NERC CIP, now I have given you the CIP standards, the list. We were particularly interested in 251A. And I have just copy pasted one of the portions of that, which is the requirement. Now, if you read this carefully, the one within the red ellipse, you will find that this is what a cybersecurity log is. So the idea is that what the standard is saying, NERC CIP is saying is, please make sure that you have a list of all the cyber assets within your security perimeter or within your industrial control system. So this is what we did for e-houses. So what we did was we, with the engineers, and in this case, it was the team of Control Infotech and SAM Analytic, along with the other, the other party. We sat down and we made a comprehensive cyber assets log, which is nothing but a list of all things that are within that e-house. Now, this is where you have the help of the standards, which says, what is a cyber asset? How do you class it as how do you classify the risk of that particular cyber asset into high, medium, low impact? All this is given in the standards. Now, we help you interpret it and we help you organize your cyber assets for security purpose, cyber security purposes. This particular slide is essentially just pointing to various references. If you have the time, please do go into this standard. It's very well written and it is a very, very useful standard for NERC CIP. The next slide pertains to an additional requirement that was given to us from the point of view of the compliance, which is that every cyber asset which is in the low impact VES cyber system should have these 4 things, which is they should have physical security controls. Like, for example, a simple thing like if you have a switch or a relay and it is not in a panel that is under lock and key, then you're actually not having a physical security control. So one of the things to do during an assessment is to check whether all the cyber assets are under are protected physically. Nobody should be able to take a hammer and just hammer a PLC or hammer a switch. It should be protected, and the key itself should not be kept next to the cabinet. It should be kept away in a secure place. Those are the small things that are important from a physical security standpoint. The third and fourth items again are specific to cybersecurity. which means that in the event that there is a problem with that particular cyber asset, is the organization taking adequate care to come up with an incident response plan? What are you going to do in the event that particular cyber asset fails in its operation? So those kinds of plans should be decided, which is what Tony was talking about in terms of documentation. So we also help organizations and teams in terms of the documentation, giving them the required content which they can incorporate into their policies. Next
Okay,
slide.
so now this would be a good time for a poll question, I think.
Okay, fine. Please go ahead.
All right, I'm going to launch this first poll. So if everybody can just check which of the following are not primary tasks required to generate cyber asset logs. Y'all can just check what you think. Well, not getting any results. Either nobody's doing it or they're not able to. Somebody can't get into that one. Shoot me a text. Oh, there we go. Now we're getting votes. Just slow and coming in. Tony and Balu, if you open up your polls, you can actually see the responses as they're coming in.
Yeah, I'm able to see the responses.
Isn't that nice?
Yeah. And it's even better, John, that they're getting the answer right.
Exactly.
Oh, that's cool.
You like that, Tony?
Yep, I can see that. Yeah, in many cases, organizing and collecting the data involved contacting each of the manufacturers involved, including the manufacturer of the Ethernet switches, the manufacturer of the motor bus transfer system, if you can imagine that. So we're talking about the automated switching and synchronization components. So that supplier had to be identified and contacted, and we had to verify serial codes and firmware revisions for the devices that are planned for this site, all the way up to the folks that make the protective relays for the transformers.
All right, Tony, I've closed the poll, so you can go to the next.
There's one thing that I'd like to add to what Tony was saying. Please understand that generating the cyber assets log is an exercise in terms of identification and classification of cyber assets. So tracking down known hackers is not part of getting a cyber assets log going. That's an activity that is done as the next step.
That's the exciting part. That's the part.
Cyber assets.
The part that everybody wants to do because it gets them into the movies. Okay, another deliverable was the report. So we had to actually generate a report that is then kept on file. It's updated every 15 months. So there's a lot more involved in responding to just one component of the specification. We've only got about, I don't know, 5 or 10 minutes left. I want to make sure that we get a chance to talk about a different kind of service that's provided. In this case, it's the penetration testing. We talked about compliance management services. Now I want to talk about some of the active testing that can be done to a system prior to its commissioning so that the user has the right level of confidence that it's protected. Here's that same picture of the primary and secondary distribution system. In this case, the customer was the end user was the traction power system and train authority for a large city in the southeast. And that city had to connect a power source to the rail lines that were going throughout the city. And so the utility and the city each had their own set of not only automation requirements, but cybersecurity requirements. And what complicated the project was that a maintenance contractor was a third party that needed access to all of the data that we were collecting using our SCADA system and our control panels that were at the substation. So now we've got three main entities, all which had to be, have access to data in order to perform their either maintenance or operation or the design function, or power delivery function. And yet they were all different entities that had different cybersecurity requirements. So the specification went out, and our systems integration team proposed a cloud-based system that would be completely separate from all three systems, that could be independently tested and give everyone access to the information that was required for them to perform their functions in managing that substation that was providing power to the rail lines. The spec that came out referenced where it was located was in the SCADA quality assurance part of the specification. So in this case, there was no appendix. It was an integral part of the specification that referred to a SCADA system that had to meet all modern cybersecurity standards. They defined what they were and made the special statement that any modifications, hardware, software, or network requirements to accommodate this level of encrypted cybersecurity systems were the sole responsibility of the supplier of the substation and not to the end user. So here we're talking about a specific contractual obligation that needed to be met. In that same spec, there was a request for a third-party licensed penetration tester. The reason that a third party was required was because there are a lot of standards and activities outside of the environment of just that one city that a tester would have to be aware of. And of course, this includes all of the potential hacking that could be done on all of the potential types of equipment that would be used at that substation. And ultimately, in the spec, we had to be able to respond to and demonstrate that these types of vulnerabilities that all parties were concerned about could be protected against, and they wanted a specific test to verify and certify that. And it included certification and proof of protection against spoofing, monitoring through reflection, and also injection of data into registers on a PLC, implementing denial of service to prevent access to a particular automation system or monitoring system, let alone getting in there and corrupting any of the data. You could see why having a company that could include in their delivery of the SCADA system the actual security and authorization, the testing that goes along with it would be very helpful. Here's a list of the most dangerous vulnerabilities that were required, but rather than just read a list of them, I wanted to ask Balu, what are the main services that these customers want? There's a wide range of potential threats. What are the main ones that they want, and how do we protect against them?
Yeah, so I'd like to I'd like to go back to the idea of security assessments. If you could please navigate to the next slide. So the thing is, we spoke about security assessments, but then how are these security assessments done? There are three important methods. They are called testing, examination, and interviewing. Now, one of the ways in which we did the assessment the last time around was examination in the first case of compliance. This time around, we are looking at testing. Now, please understand that in the case of the e-houses, the main building block was relays. Whereas in the case of the traction power project, the main building block is a PLC. So I'd like you to please go on to the next slide, where we just look at various aspects of penetration testing. So the idea is that during the cycle of penetration testing, we try to identify a target, and then we are going to try and find weaknesses in that target and see whether we can exploit the particular weakness. So for example, a port on a switch is left open or it has not been configured correctly. So what somebody could do is that if it's an Ethernet switch, they could just go and plug in Ethernet cable and perhaps get access to that particular part of the subnet and do damage there. Now that would be an example of a malicious attack using an open port on a switch. So the idea of pen testing is to try and simulate certain kinds of attack vectors and make sure that the information system and the security team manning that has taken care of those kinds of eventualities. So we are basically trying to identify and fix vulnerabilities within an information system when we think in terms of penetration testing. If you could please go on to the next slide. So here, I just want to show you, given a network of these, let's say, components, if you can look at the first step by pressing, if you can just press a key, please. So first testing is you are directly communicating with the PLC. So the laptop is connected to the PLC on a particular port using a particular protocol, and you are giving all kinds of random inputs to the PLC. That's first testing. Okay, I'm being a little brief here simply because of the time that is available to us. Now, switch assessment is when you are going to look at what is the expected configuration and what is the actual configuration. You're going to compare the two configurations to make sure that the people who have set it up and installed the switch have actually conformed to what is required. In the next one, there is something called SQL injection. SQL stands for Structured Query Language. Now, this is used in order to communicate with databases. So in the case of SQL injection, what the attacker is doing is trying to exploit a particular weakness in the way your SQL queries and the way the SQL queries are constructed and handled by the application. Typically, SQL injections can be done in several ways, but they are done through the HMI, or they are done directly through a system which is connected to a database. Or typically, databases are historians in the case of an OT network. The next thing is the next kind of test, or the next kind of vulnerability to look for is using a cross-site scripting. So here what happens is that mostly cross-site scripting is to do with web applications. And in this particular case, a script typically refers to JavaScript or some script that runs within the scope of a browser. So essentially in cross-site scripting, you are taking control and running a program of your choice or the hacker's choice rather than running the actual program. So that is cross-site scripting for you. So those cross-site scripting specifically is to do with web services, either on a PLC or somewhere else in that particular OT network. So these are some of the ideas in terms of penetration testing or cybersecurity services in general. I leave you with this. If you have any questions, you can always send me an email. You have my contact information, or just reach out, and we are there to help you.
Okay. Let's see. So this is, we can, hey, John?
Yeah. You want to skip it?
I can wrap up while you do the poll question, or?
Okay, that'd be great. Or do you have, is that your question? Last slide. Okay, it's up. Go ahead, Tony.
Oh, so the question for the poll was, what systems and devices are tested? And as Balu just reviewed, it was the automation system that included the network, the switchers, the controller HMI, the SCADA HMI, everything that's in the e-houses and the substations that are delivered on a large project. So the fifth item there was any kind of restricted item that you might have with you personally, which is, of course, my joke question. So it looks like you guys are answering the question. I've given you the answer.
Yeah, so I went ahead and closed it.
Okay.
Your
So, thank you. We covered two examples.
Tony and Balu, we have a couple questions I'd like to address.
Okay.
Can you the questions that are up there? Or do you want me to read them? So the first question is, will there be details on testing cybersecurity in e-houses? What standards apply? What are the typical issues that are found and needed to defend in terms of cybersecurity? So far, this is a sales pitch for Control Infotech. I don't know about that, but
that's okay. So will there be details on testing? Yeah, at the end of the presentation, we included the actual type of physical or threat testing that we would perform for the devices in a substation. Those are the same types of tests that we had proposed for the traction power substation. So all of these were tests that were evaluated by the users when provided with a set of NERC requirements on a project. So the details of this are available in a follow-up webinar, to be sure. The actual standards involve government standards as well as the standards of the end user that has their own cybersecurity requirements. So it was, in some cases, a policy that was written and, as Balu described, supported by the National Institute of Science and Technology and coordinated through the government. And in other cases, it was basic concerns that the end user, like the traction power people or the utility, had with getting access to their information that they were trying to protect.
So one of the things I'd like to add to what Tony is saying is, when it comes to the deliverables from any kind of cyber testing, we talk in terms of reports, and reports are typically reviewed along with the entire team and all important stakeholders as part of the deliverable. So there would be a format which should be mutually accepted between the between us and the target organization, and we will then put all information collected, the kind of testing we have done, when we have done it, on what kind of cyber assets we have done it, what was the outcome, what should have been the outcome, what kind of mitigation strategies we are going to suggest, because we also need to give them a way to fix it, just not identify a problem and leave it at that. So all that is going to be part of the reporting. I hope that answers your question.
It does. I think I've got one more question that was asked. The person said that they felt disgruntled employees are one of the main sources of cyber attacks. What besides a radius server, and you may want to explain what a radius server is, can you do to prevent disgruntled employees from cyber attacks?
Yeah. So what happens is that one of the key things when it comes to cybersecurity is a particular idea called access control. So it's like there are certain, imagine a space which is having several rooms, and every room has a door which has a lock and a key. Now, you need to have permission to enter a certain space. In a very, very similar way, in cyberspace, you would be given permissions to enter certain specific areas of cyberspace. For example, access a machine, access a PLC, access a program. Now, the concept here is that the way you access physical space is using a lock and key, whereas in cyberspace, it's called an identity and a password. And that whole thing is called Identity and Access Management, IAM. Now, IAM is a separate service. And when we think in terms of radius, what we're actually talking about is that how are these identities established and how is the identity given access to a particular resource. All that is governed by that particular idea of radius. If you have further questions on this, I would suggest that you just read up about radius or come back to me at a later point or through email, and I should be able to give you more information about it.
Great. Tony and Balu, thank you. Y'all did an awesome job on this presentation. This will be posted to our website. It takes about 4 hours to get it processed. It'll be up there after that. I want to thank everybody for attending today. We've got some questions for the rest of the week. Thank you.